All right, so this will be the last of the neurobiology lectures. And so we're going to do one more thing with some hormonal stuff. And so we have a plain midshipman, which is a fish. And there's actually two types of males. There's type 1 and type 2. So again, we kind of mentioned, we'll talk about more, but the name of the game is to get your genes in the next generation. And that's how you're Darwinian fit. So how do we do that? How do we accomplish that? And so there's males that are doing two strategies. There's the type 1, they build, not tests, they build nests. And I'll have to fix that. They're 4 times larger than the type 2. So they just have more girth. They have larger gonads, which means they can produce more sperm. And they are more vocal to attract females. They grunt, they hum. And then the type 2 male doesn't build a nest, and they're called sneaker males because they sneak in. They're small in size, they have small gonads, and they occasionally grunt, but not a lot of noise. All right, so what we're doing, and here we are, we're looking at them over here on the right. Here we have the big dominant male. Here we have a female, and then here and here we have 2 sneaker males. And so the idea is they will come up and try to, as she's laying eggs, try to fertilize them. And the male here, this is a male now with the brood. They've been fertilized, and he will watch all the babies. All right, so this plain fin midshipman has a couple of different hormones. There's actually a few. Melatonin is one, but this study did not look at melatonin. But this one dealt with 11-KT, which is a type of testosterone found in fish, and then cortisol, which is a stress hormone. And what they found is higher levels of the testosterone and low levels of cortisol are associated with increased male sound production. So a male that had high levels of the KT, 11-KT, and low levels of the cortisol were the ones that were louder. So the question is why? What's the here's the hormones. What's causing this? And what they found is it's sonic muscles, and you can see in the picture here these larger muscles, and they're attached to the swim bladder. The swim bladders in a fish is basically to help with buoyancy to keep them up, but it's a fluid-filled sac, and if you put muscles on that and vibrate it, it's going to generate noise. And so type 1 males have larger sonic muscles with more muscle fibers, so they're denser. But type 2 males also have these sonic muscles. So it's not that they don't have them, it's just bigger in these type 1. And then the other one is they have pacemakers. They're innervated with pacemakers. And now we have a pacemaker in our heart. That's the SA node, or sinoatrial node of our heart. And that gets the heart to beat at its rhythm. And so the idea here is that if you have these nerves and their sound is very rhythmic, and it causes the neurons to fire 15 to 20% higher rate, which actually has a more booming, repetitive sound. So again, these hormones are causing this. So again, we want to make sure both systems work. But we're looking at fish sounds, and this is also, they've been doing a lot of studies with very similar responses in things like amphibians, male frogs, and things like that. So hormones matter. And then the last thing, which is often talked about here, and there was another good place for it maybe in our lecture, so I did want to mention it, was sleep, and I know you want to sleep through my videos, and I apologize. But there's cool. Some of these animals have the ability to sleep with one eye open. Wouldn't that be better? You're sitting in a lecture and half your brain go to sleep, the other half to pay attention, instead of the usual where you just don't pay attention at all. Mallards can sleep with one eye open. It's called unihemispheric sleep. It's not just ducks. We also see it in lizards, especially when there's predators around. My office mate Tim Ravel got his PhD looking at, that's part of his thesis. He was looking at desert iguana and their ability to do this sleep with a rattlesnake nearby, which is a predator for them. All right. So anyway, so mallards have the ability to sleep with only half their brain. So the idea behind ducks is, you know, if they're floating around, they are susceptible to predators, birds, and other things, coyotes, depending on how close to shore. So they'll group together for protection. And what they find is the birds that are in the middle will sleep like we sleep, both eyes shut, or at least more of them will. And then what they find out is the ones that are on the edges, where there is more fear of predation, they will have do the unihemispheric sleep, where they have one eye open, and it's usually pointed out toward the outside. You know, they may be looking a little bit on the inside, but the predator is coming from the outside typically. Or if it does come from the other side, somebody else is going to become aware of it and put up an alarm call. So it makes sense, you know, that depending on where you are, you know, and again, there are some ducks that are clueless that are on the edge with both eyes closed, but for the most part, you know, the most of them are using this unihemispheric sleep. And then what we also find is it's not very common in mammals, both of it, but there are some certain mammals that we think need to. And again, it's, you know, we look at the ultimate cause, and in ducks and maybe lizards is predation and the fear of dying. But for marine mammals, they're very large. And so the idea maybe, you know, depending on which one it is, there may be some fear from some larger animals, like for dolphins, maybe an orca. But marine mammals have the other problem is you're in the water and you need to be able to breathe. They're air breathers. So these aquatic animals, these aquatic mammals, are sleeping with half their brain. And you can see the activity here, where it is, you know, left side is very, very active. I'm sorry, this is the sleep mode, very sleep. And then the right side is active. And then they flip and they do the other side. Both sides get to sleep. And we need sleep. We know there's reasons, you know, we thought to clear toxins is a reason that has been given. There is that we can kind of sift through all the information we saw for the day and categorize and get our brain to put it in the right spots. We do know that if you are held awake for too long, it'll kill you. They've done studies on mice where they just wouldn't let them sleep. There was a shock every time they started to try to go to sleep in REM sleep, and they died within like 3 days, I think it was. So you need sleep. Not through my lectures, but that's it. That'll be the last lecture. So we will stop the share and we will stop the recording.